Hello, how are you? Are you there? Hello? Hello, Valeria Gomez, Inés, Miguel. Can you hear me? Please leave the chat. Don't contaminate the chat. Are you there? Tell me something. Pablo Laborda, are you there? Are you? Sandra? Can you hear me? Tell me something. Tell me something, please. Are you there? Okay. Hello, Celia. How are you? Hello, Pablo. Hello, Julia. Good. Very good. So, let's get started. Please go to your exercise part, your notes. We have some exercises to correct. So, remember, exercise number 4. We're talking about heat energy, and you have there an exercise about this picture that represents two different bodies. So a hot body, and B, a cold body, and they had different temperatures. You can see here the thermometer. This is high, this is low, and then the first step, they are in contact, and as a result, the heat from the red object transfers to the blue object, and as a result, the whole system reaches an equilibrium. Okay, but remember, it's the hot that goes to the other part, not the other way around. Not the other way around. So, how does heat travel? By moving from the hotter object to the colder object. Okay, not the other way around, until it reaches an equilibrium. And I want your participation in this exercise number 5. So, let's read it. So 5.1. If two objects have the same mass, the object with the higher temperature always, and you can choose between A, has greater thermal energy, higher position, feels warmer, 2 of the above. If two objects have the same mass, the object with a higher temperature, okay, is D. D is correct because A and C are right. So, the object with the higher temperature has greater thermal energy and feels warmer. Now next, 5.2. Which of the following statement about temperature is true? Temperature measures heat. No, no way. Temperature measures kinetic energy. Temperature is the same thing as heat. No way. And D, temperature is the same thing as thermal energy. No way. So the only right answer is B. Good. 5.3. If a bucket full of water and a cup full of water have the same temperature, then the water in the bucket and cup have the same thermal energy. No way. The bucket has greater thermal energy. Remember, we have a bucket and a cup. So, B could be cup has a lower average kinetic energy. No, necessarily. And the cup has lower temperature. No, necessarily. So the only correct answer is, in this case, B. Very good. You have to correct it. I correct your words, but not all of you, because not all of you sent them to me. So, 5.4. If you put a cool spoon into a cup of hot coffee, the temperature of the spoon rises because thermal energy is transferred from the coffee to the spoon. Temperature is transferred from the coffee It's the same. Sorry, thermal energy and temperature is transferred. Temperature is not transferred, only is thermal energy, which is transferred. Particles of the spoon gain kinetic energy. No. Two of the above. No. The correct answer is A. A. It could be B as well, because finally the system reaches the same temperature. So you could say A and B, so D. Very good. So 5, 5. Which of these statements is true? Only warm or hot objects have thermal energy. If particles of an object start to move more quickly, the object's temperature rises. Temperature is the same thing as thermal energy. We know that this is wrong. And D. Thermal energy always moves from an object with a lower temperature to an object with a higher temperature. Impossible. So C and D are wrong, and A is wrong, because no matter the temperature, all objects have a thermal energy. So the only correct answer is, in this case, B. Very good. Now go to our text part. Now we're going to study about the transferring of thermal energy, and you're going to, you know, because you studied it the other day. So heat can be transferred in three different ways: conduction, convection, and radiation. Good. And before starting, I'd like you to watch some videos. And remember, if any one of you is interested in these videos, the only thing you have to do is to let me know it. So pay attention now.
Perdona,
Excuse me.
Yes.
¿me puedes decir cómo llegar a...
This water boiling, the heat of the fire, and cooking on the skillet are all examples of heat transfer. In simple terms, heat is the transfer of energy from objects of different temperatures. As objects warm up or cool down, their kinetic energy changes. Kinetic energy...
Remember that kinetic energy is the energy due to movement. In this case, the movement is the movement of particles, of atoms, and electrons in an object.
is the energy of motion. Temperature is a measure of the average kinetic energy of the particles in an object. As temperature increases, the energy of motion increases. As the water warms up and the temperature increases, you can see an increase in the movement. Heat can be transferred in at least three ways: conduction, convection, and radiation. Conduction is a process in which the transfer of heat takes place between objects by direct contact.
This is important. So conduction, you want to study conduction, you need two different objects, and they are in contact. So normally with solids, but they need to be in contact. And this is the way by which the hotter object transfers the thermal energy to the colder one. So conduction, two objects in contact.
It is most often associated with solids. The key to conduction is direct contact. The heat of the pan is transferred to the mini pizzas. The energy of the frying pan is transferred to the eggs. Notice that they are in direct contact. Convection is heat transferred by the movement of a fluid such as air or water when the heated fluid is caused to move away from the source of heat.
So pay attention now. Convection is a way of transfer of heat energy that needs two fluids. Fluids could be a liquid or a gas. Remember, conduction, two solids in contact. Convections, fluids that could be gases or liquids.
Carrying the energy with it. It occurs due to density. Lava lamps are examples of convection. As the liquid is heated, it rises and falls. as it heats and cools. As the paper burns, the air is heated up and begins to rise. The burning paper is swept up in the convection current, cools, and falls back down.
Can you see that? So in a convection experiment, the heater air or fluid goes up. Okay? And as it goes up, then up there is cooler. It's cooling down. And it is cooling down, it goes down and sinks. Okay? And this creates a wave. This is convection.
These beans are another example of convection. As the beans warm up, they rise and then cool and fall back down.
Can you see these beans? These beans are being heating up, okay? And as they are heating up, they go up. Okay? When they reaches the higher level, they start to cooling down, and that's the moment in which they are sinking, going down. This is convection.
And repeat this over and over again. Radiation heat is transmitted without any physical contact between objects. Watch how the temperature of the lamp is transferred to the thermometer without touching it.
And radiation doesn't need any contact at all. So we are receiving heat from the sun and we don't touch the sun.
These alligators and lizards use radiation from the sun to warm their bodies. If you'd like to know more about heat transfer and conduction, convection, and radiation, this playlist will help. And as always, thanks for watching, and Moo Moo Ma.
Good. Now let's go to our text part and try to read the text about conduction. So you can see here a picture. You have here a candle and here a stick, maybe made of iron, and the thermal energy from the candle is in contact with this stick. This metal stick is transferred by conduction. So the hotter object in contact with one of them, with another one that is colder, transfers its heat energy to the colder one. And you have here the 4 bullet points that are important thing in this case. So conduction, transfer of thermal energy from one object to another when they have different temperature. The warmth will be passed from the hot to the cold object, and conduction continues until both objects reach the same temperature. And conduction transfers heat energy in solids in contact. And there are some different materials. One of them are heat conductors, and there are others that are heat insulators. So heat passes easily through thermal conductors. So examples are stoves, matches, okay? And heat doesn't pass through thermal insulators. Example of thermal insulators are plastic, cork, or wood. And good insulators are poor conductors. And now that in mind, go to the exercise number 6. And you have here some different objects, and you have to classify them between insulators or conductors. You have here a coat, and we put on this coat to keep us warm. So to keep the heat from transferring. So this is a very good example of an insulator. This is a fry pan, transfer heat from the fry pan to the eggs. Good example of a conductor. This door is an insulator. We want to keep our room warm. We should close the door, okay, to insulate our room. And this is a gap. It's an insulator. This is a stove. So this is a heater. Sorry, this is a heater made of metal. It's a wood sample of a conductor. And this is a pullover. We put on this pullover, same as this coat, because we want to keep us warm. So this is a wood example of an insulator. And this another example of a very good conductor. Gloves, insulators. This is a light bulb, a conductor. Blanket here, insulator. These two kind of shoes are insulators, and this teapot is a conductor. Good, very good. And then we have the exercise number 7. So what do you think? Number 1, metals are good thermal insulators because heat passes through them quickly. And this is number 1. I'm waiting for you. Number T, you think this 2 or 4? Good, very good. This is false. This is false. Number 2, because a blanket is not a good conductor, it works well to keep us warm at night. Is that true? Yes, number 2 is true. Number 3, insulators often contain pockets of trapped air, like feathers on a bird and fur on animals to keep them warm. It's true. It's true. Many of our coats have air inside their fabric. Heat loves to travel and will travel from a colder material to a warmer material. From a colder to a warmer? No way, no way. This is false. Number 5. You boil a teapot on the stove, the pot becomes too hot to touch, whereas the teapot handle does not get hot. That's true. Why is it? Because the handle is an insulator, normally plastic, rubber. Number 6. Wood and plastic are good heat conductors. Wood and plastic? No way. No way. This is false. 7. Thermal insulators are good for keeping heat out as well and in. An example is a thermos. What do you think? Yes, you can use a thermos to keep your liquid warm or cold. It's true. Number 8. Metals feel cold when you touch them because they take heat away from your hand when you touch them. What do you think? It's true. It's true. Okay. If you touch cool metal, you are transferring your heat to the metal. That's why the metal feels cold. Good. Number 9. Wood, clothes or blankets feel warm when you touch them because they don't take heat away from your hand when you touch them. What do you think? It's true. And finally, number 10. That's why metals are good heat insulators, and wood, clothes, and blankets are good heat conductors. Do you agree with that? No way. The opposite is true. Very good. So go back to our theme. Now I want to talk about convection. And about convection, remember, but convection is the transferring of the thermal energy in a fluid. And you have to know that a fluid is or a gas or a liquid. Okay, good. So, and I have for you another different documentary about conduction. So pay attention.
Conduction. So, here we see two likely lads toasting some marshmallows on an open fire. One of them has chosen a metal rod to put their marshmallow on the end of, the other one chose a glass rod. Which one of them do you think is going to burn their hands on their rod first? Well, let's wait and see. Oh, there we go. We can see it was the guy with the metal rod. Why do we think that was? Well, actually, it's because metals are much better at conducting than glass. Glass still does conduct, just not as well. Let's zoom in and look at the particles in the glass and see how it conducts. So glass is a typical solid in the way it conducts. The particles by the fire start to gain heat from it and start to vibrate much more vigorously. They then collide with the particles next to them, passing on the energy, and slowly down the rows each particles vibrate more and more vigorously, passing on heat to the next one through collisions. So it progresses slowly through the glass. This is how...
Okay, so this is another example of conduction. And what I really want you to watch now is the explanation for convection. And you have here an experiment. Now,
Alright, so here we have a way to demonstrate convection, which you normally wouldn't be able to see. But in this case, we have this container, which is half filled with cool water. It would be wonderful if it was ice cold. That might even work better. But this represents part of the atmosphere or the air. And then we're going to put 3 drops of food coloring. One in the middle, which will be red, because that's going to represent warm air, which we'll show you in a minute. And then we're going to put 2 sections of blue food coloring on either side, and that will represent cool air. When we move the hot water underneath the red food coloring, that will represent the uneven heating of the Earth's surface. And we will see what happens here as we add some hot water. And I will zoom in here. So again, the hot water represents the uneven heating of the Earth's surface, which should create some extra warmth in our atmosphere there. And we're going to watch this red food coloring closely. If all goes well, it should start to rise.
can you see? The red liquid is going up. Why? Because it's heating up. It's being heating up here. And this is the blue liquid that is going down. Okay? Because it has lower heat energy.
And there we see, if you look at the bottom of the food coloring, we can see the food coloring start to rise, which means our water is warm enough. And so that's creating an area of low pressure as the hot air rises. And as it rises, we can already see that the blue food coloring, which represents the cold air, is moving in to replace the warm air that is rising. So it's moving into that area of low pressure. And that is a good representation of convection, which creates air movement or wind.
So that's the way in which air is moving. So when there is air that is being heated up, it goes up, and its place is occupied by cool air. Good, very good. And now please go back to our material. So convection is the transfer of thermal energy between moving liquids or gases. They are called fluids. The heated molecules take up more space and rise to the top, while the cooler molecules sink to the bottom. Can you see? This blue color represents the cold molecules of water that are replacing the place where before the warmer molecules were settled. An example is the movement of the air, the sea, currents, and heaters. And the other example is radiation. Radiation is the transfer of thermal energy with no particles but heat waves. So this is called an electromagnetic wave. Okay, and you don't need to be in contact to transfer heat energy. So heat or light waves are radiant energy. This is another word to say radiation, radiant energy. And these heat waves go out in all directions until they are absorbed by objects. An example is the heat coming from a fire, from the sand to the earth, and so on. And I have here for you another
Welcome to Moo Math and Science and Atmospheric Heating. The Earth and its atmosphere is warmed by the energy from the sun. In this video, you will find out what happens to solar energy as it enters the atmosphere. Three things work together to transfer energy to our atmosphere: radiation, conduction, and convection. Radiation is the transfer of energy as electromagnetic waves. Although the sun radiates a huge amount of energy, the Earth only receives a tiny fraction of this energy. But this small fraction of energy is enough to drive the weather cycle and sustain life on Earth. Thermal conduction is the transfer of thermal energy through a material. Thermal energy is always transferred from warm to cold areas. When air molecules come in direct contact with the warm surface of the Earth, thermal energy is transferred to the atmosphere. And convection is the transfer of thermal energy by circulation or movement of a liquid or gas. Most thermal energy in the atmosphere is transferred by convection. For example, as air is heated, it becomes less dense and rises. Cool air is denser, so it sinks. As this cool air sinks, it pushes the warm air up. The cool air is eventually heated by the Earth's surface and begins to rise again. And this cycle of warm air rising and cooling causes a circular movement of air called a convection current. Now, as this energy from the sun enters the atmosphere, several things happen. First, about 25% is scattered and reflected by the clouds and air. 20% is absorbed by the ozone clouds and atmospheric gases. About 50% is absorbed by the Earth's surface, and 5% is reflected by the Earth's surface. So all of this working together, the radiation, the conduction, the convection, and then the sun being either reflected, scattered, or absorbed, causes atmospheric heating. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and share.
Good. Now you have to do some exercises. I wrote you these exercises, and I'd like you to to change theme, and you're going to watch some presentations, fantastic presentations that were made for some of you. I don't know if we'll have time enough to see the whole of it, but if we don't have time today, maybe we can have time any other day. Now, I'd like to start by a presentation made by Celia, a beautiful presentation about Velázquez. You remember that Velázquez is one of the most important, not Spanish painter, not European painters, but painters in history. He was Spanish. And you know that. So this is the master of painting in the Spanish Golden Age. Very good. And he ranks along with other painters such as Goya or Picasso as the most important painters, along with other people from abroad, in history. It's a kind of introduction. This is our man. This is Diego Velázquez. Okay, it's most important painters in the history of art. Okay, and he painted in Baroque style. Baroque style is a style that has some features. One of them is that they play with colors, with bright colors and with dark colors. Can you see here? Okay, that was Velázquez. Good. He was born in Sevilla. Okay, and this is Sevilla at the time. Okay, this is Guadalquivir River. Okay, good, very good. So, all these ships, boats, were on the Guadalquivir River at the time. Good, very good. And Celia tells us about his master. His master was called Francisco Pacheco. Okay, good. And this is a really awesome painting. So this is a normal scene in the Velázquez time. This is an old woman. This is frying eggs. This is a boy, and if you look closely, you can see the eggs. You can see the eggs here. Okay, good, very good. It's then from Sevilla, Velázquez went to Madrid, and this king Philip IV, saw Velázquez work, and he said, "Okay, I want Velázquez as my painter," and Velázquez became the painter of the king. Not only the king, but the court. Okay, this was King Philip IV. Good. And he wanted to learn more about painting, and he went to Italy to learn more and more. And in Rome, he learned many things. And this is a very interesting painting that represents a mythologic scene. Okay, these are gods and goddesses. So you look closely, they look like ordinary people. This is the god of the fire, volcano. Okay, this is another god. This is conveying, this transferring some but not news to the god. We have another work about this picture. These are some more portraits by Velázquez. Okay, this is the king's son. Okay, you see here. Can you see how fat is this horse? Is so because the painting was destined to be above in an elevated position, and it was kind of prime minister, Conde Duque de Olivares. Was painted by Velázquez, a very interesting character in the history of Spain. he prided himself of painting ordinary people, and this was a person, a kind of clown of the court, okay, a dwarf, and Velázquez paints him with all his dignity. Can you see here? Good, very good. And he went twice to Italy, twice, and he learned to paint more and more things. This is a landscape, an Italian landscape, and this is a very famous painting by Velázquez, okay? In Spanish, La Venus del Espejo. Okay. I think you can see this painting in London, I think. But maybe one of his most famous works is Las Meninas. These girls are Las Meninas. Meninas, this is a Portuguese word that means little girls. Okay, these are the daughters of the queens. Sorry, the king and the queens, monarchs. Here in this mirror, you can see the king and the queen that are being painted by Velázquez. This is Velázquez. Okay? Okay. And these are clowns that were living in the court. Very good. Very good. So he was a genius of painting, that's true. Very good. And we are lucky. Celia tells us we're lucky because we can see his painting in the Prado Museum. That's true. That's true. Very good. So this is the presentation, and I'm afraid I don't have much time to see more of them. But I like you to take a look to this presentation that was made by Julia. This is Velázquez. Okay, this is a kind of self-portrait. You can see in this image in the Meninas painting, and these are dates about his biography. Okay, and this is another interesting work. You can see it in Prado Museum. The Feast of Bacchus. Bacchus was a Roman god. Okay, the god of drinking, of joyfulness. Okay, they represent Bacchus as a drunkard in many paintings. But if you look closely, you can't see God here. Just normally people. These are ordinary people, all of them. Okay, good. So Meninas is most famous, one of them most famous works, and King Philip IV. Good, very good. And these are mythological paintings. We talk about the Vulcan Force. Okay? These are gods from Roman times, and this is another picture that has two different readings. This is called spinners, las hilanderas in Spanish, and you can see this picture as a picture of ordinary people that are working with fabric to make clothes, or you can see another different story. Okay, I want to talk about that in another work. Good. So here the spinners, or the fable of Arachne, una fábula. So this is a kind of story with animals. It's this is the story. We don't have time to read it now, okay? But we're going back to it in other moments. Very good. So congratulations to the two people. In this case, Celia and Julia, and there are two more of you that made beautiful works about Velázquez. But we don't have time now, and I have to tell you goodbye. until just an hour more or less. Very good. Very good.